Hello everybody. Can everybody at the back hear me properly? I speak pretty loudly, so all good. My name is Adriaan Rowan. I'm from Numbers Boost, and I'm going to talk about the blessing and curses of high dimensionality. Just a little bit of background of myself. I'm an actuary by background. So in the insurance space, I always talk about insurtech and how it's going to disrupt the insurance space, and they're all very concerned about their future and if they're going to have a job in the future. And it's actually the people sitting in this room that's going to be people doing the disruption. That's one of the reasons I'm so interested in big data and machine learning and all the things that we can do here, because it's really sort of the mix of skills that you find in here. It's not just actuaries, not just computer scientists, not just the statisticians, even though we all claim to be like the owners of big data and the true data scientists. It's this mix of skills that is really sort of creating the search space that is necessary to solve the problems of the 21st century. So it's great to be able to sort of just meet you guys and speak with you and learn from all of you. So I'm going to talk about the blessings and curse, but one of the angles I want to talk about is the ethics around it. Now, in one of the other rooms, there's an entire session around the ethics of AI, so I'm not going to go into that much detail. But I think it is important that when we talk about the curses, we shouldn't just talk about the disadvantages, but also things that can go wrong, and how we apply big data is very important to make certain that we build towards a better 21st century and not just be part of the problem. So on that note, I was wondering, does anybody know what company's logo that is? Anybody? Say again?
Based on the words next to it, I guess Cambridge Analytica.
Very good. So, yes, it's Cambridge Analytica, which probably a few years ago everybody would want to be like Cambridge Analytica and wish their models would be as good as Cambridge Analytica. But suddenly it's not sort of the company you want to be associated with, and in a way we are, by implication, not the profession that wants to be associated with that. Which makes me think about all the things. I mean, we talk a lot about like computer vision and being able to identify people's faces. And that is all sort of benefits about making certain that people look at the right products and offer them the right products, etc. But it also allows for scope for discrimination if your model is incorrect. Somebody can look at your face and see, I don't think this guy is going to be able to afford my shoes. I'm rather going to offer him something else. Or just sort of start treating people differently based on sort of your models without really understanding the implications of the models. So it also makes me think a lot about, I mean, we trust, who knows this logo though? We know that one. We know that one. About sharing our information. I mean, Google knows everywhere you go and all the photos that you take. And if I were to walk up to any one of you and tell you, can I please read all your messages on your WhatsApp and all your all your Facebook messages, would any of you allow me to do that? Or if I tell a girl, can I please follow you around every day for the week, everywhere you go, just so I can give you a better service? I mean, you'll report me to the police. Yet we willingly give our information to these companies in order to improve the services that they give us. Which makes me think about, so I'm an actuary, so I work in the insurance industry. And in many ways, actuaries were the data scientists and also the Cambridge Analytica of the 19th century. We were the first people to aggregate data on a large scale, and we're the first people to exploit the asymmetry of data, that we know more about the person that the person knows about on his own about his mortality. And that allows us to give him great products. We're allowed to give him insurance products that he wouldn't be able to get on his own, afford on his own, and it's a great service when somebody dies to be able to pay out life insurance, or when somebody becomes sick, that you can give them income cover. But if you take it a step further, if we know from all this data that there's a 95% chance that you're going to get cancer soon, and then we don't give you cover, I mean, in a way, it's the right thing for us to do because it protects our profits, but it's sort of, there's a moral dimension towards it, like how we used it. And the flip side is soon customers are going to be able to like do self-testing kits and see if they're going to get cancer or not. And then they're going to take out as much cover as they want. They're going to make profits from the insurance companies. So how do you balance those two? Yes, but if it becomes unaffordably high, then the person cannot actually afford it. There's no companies that if you have HIV for a long while, if you had HIV, nobody would give you insurance cover, no matter what premium you would pay for it. And because it targeted the low income, they wouldn't be able to afford the cover if you loaded it for that amount in the first place. Yes. So there is that solution. So the solution of the company that I don't want to mention names, but All Life is the company's name. So apologies for saying it. I'm not trying to promote them in any way. But what they do is trying to help their customers monitor their HIV status, their CD4 counts, and therefore ensure that they don't die in that way, and then bring the premiums down if they react positively towards treatment and take care of their own treatment, so take ownership of their own data. So that is a situation where you have a two-way direction of work between the holders of data and the people actually on who you're applying it. So I'm going to touch on those things later, but those are the sort of ideas that I think it's important that we as the practitioners of this need to start thinking. It is important for us not just to find the correct premium and find out what is a premium that we should charge this person, what's the fair premium, and then charge them that, but also think how we can change the question, how we can change the product, how we can change the applications of it. Because as confusing and crazy and difficult as some of the topics are discussed today, and I'm an actuary and I've been doing data analytics for a while now, some of these things I don't have a clue how it works. So for other people, when they look at it, it is close to magic for them. So it is also then our responsibility to make certain that we use this data and use this power we almost have in a positive sense. Yes, so without going too much in it, I do want us as a profession to also start thinking about it, because other people who do not have the ethical inclination of it will use the data like Cambridge Analytica in a negative way. And it is also up for us to think about how we're using it and make certain that we implement in a way that's beneficial to everybody and not just our own bottom line. So with all that said and done, the last thing I want to say is around POPI and sort of the data security around POPI. And I always thought it was a big pain, but maybe it's something we should all know and be aware of, the Protection of Personal Information Act, if those who don't know what is POPI. We should be aware of the implications and promote it and use it to the benefit of our client where possible. The thing I want to touch on next, though, is that luckily we don't need to have somebody's information. It doesn't have to give it to us, even though it just clicks yes to the terms and conditions and then gives all the information to us. One other thing on that. Who has Instagram on their phone? And lots of people. I did this experiment the other day. If your microphone is on as one of the settings with Instagram, even though your phone isn't on and Instagram isn't open, if you were to say car, I want to buy a car, I want a Land Rover, then like a few minutes later, like an ad for a car will pop up, even though Instagram isn't open and you didn't type anything Land Rover related onto it. Which makes you think how much they're actually listening to you and watching through the video without getting paranoid. I'm not a paranoid person, but that did make me paranoid. So yes, so the curses, that is sort of the one side, the curses and the blessings of high dimensionality. On a more practical side, the one thing that we have seen is that the benefits of high dimensionality or more data, the first of the benefit, the more data you have, the better your model becomes always. So quantity of data is always good. And one of the benefits of it is that model complexity isn't always a good thing. Just because you can build a neural network with 1,000 layers doesn't mean that network will be better than one with 2 layers. So model complexity isn't always good. But if you've got more data and higher dimensions, then a nearest neighbor model, which is much simpler to understand, will probably give you a much better explanation of the results. Now, as a video, I'm just going to quickly exit here and show this. And this is the reason why, if this shows, here we go. This is the reason why more data is always good. It's because if you only look at a problem from one dimension, then there's no separation of the data. And that's on the right-hand side. But the more dimensions you have, it gives you the ability to look at something from all sorts of angles. And once you've looked at it from 3 different angles, now you can see there is actually quite a good separation of this data set. Now you can use PCA and all sorts of things to then reduce the dimensions again, and just use 2 dimensions and it will give a good separation. But that is basically, in a nutshell, why lots of data and high dimensionality is good, because you can separate the data this way. Another thing is the data becomes far from each other. So to have categories, clusters, becomes easier. Cluster analysis becomes easier and your clusters are more clearly defined. But the big curse of high dimensionality is that your test sample and your training sample, or your training sample and actual real-life data, is not reflective of the same distribution. If the distribution becomes bigger and bigger and bigger, then the odds of your training sample actually representing real life becomes smaller and smaller, and it means your real-life error rate will be much higher than your training error rate, and the wonderful results that you predict will not materialize. So that's the problem of very high dimensions. Then I'm going to go back to this. So, as I was saying, the advantages of big data and the era that we live in is that we don't need to take people's data without them being aware. There's really a lot of open data out there. So we're not trying to look at any one person specifically. We just make use of all the data that's out there. So this is an example of census data. Well, a combination of census data and information that we scraped from the internet from store locations. So how this was applied was a launch lab competition that NUMBERE won for Media24. And the question is, they had people defaulting on their paying for the subscription. And you want to encourage people to go and pay their outstanding subscription. By knowing their location, instead of just telling somebody, can you please pay your 200 Rand outstanding amount, you can tell them, please pay 200. The closest location for you to pay it is a click store that's 200 meters away at this address, which makes it a much more compelling argument or encouragement for somebody to then actually pay his bill. And you can also then split it by income group. So somebody in the low income group might want to go to a post office. And somebody in a high income group might want to go to a Woolworths. And now you can offer you can like dynamically adjust the message that you send the person to make it a lot more useful message, and the person will react to it positively. And I feel that is a positive use of big data. And that is a service that you give the person to make certain that he will find it easier to make the payment. My argument, yes, you can. I mean, we should discuss this. We should discuss if is that discrimination against a person or not. I feel in that case we're not denying the person to make the payment, the ability to make the payment, and we are tailoring it so it's easier to tell a person in a low-income area to pay it at a Woolworths when the closest Woolworths is 30 kilometers away. That's discrimination in my eyes. So, yes, I understand your argument. I'm not saying I've got all the answers. I think this is something we should discuss. Yes, so the payment rate went up a lot for it, and it's applicable in all fields. I mean, if you are giving online vouchers or vouchers to people, if you give a 50 Rand voucher to somebody with a high LSM, he probably won't react positively towards it. It's not worth his while. So you can also calculate customer lifetime value, all sorts of metrics, not just these sort of things in his income, things that you know about him, and then tailor the sort of message that you give the person to make certain he reacts in a certain way. Again, maybe that's discrimination, maybe what you offer him and not telling him what the alternatives are. And that's something I'll touch on later. That maybe one way around it is to make certain you give somebody alternatives. So instead of telling a low-income person to take a funeral policy, because you'll know he'll take it and you'll know he'll make lots of money out of it, tell him ways that he can get a proper life insurance policy that will have much lower premiums. Tell him what sort of things he can do to improve his life expectancy so that he can qualify for a lower premium rate. For somebody taking out loans, if you can sell somebody a loan at 20%, then a bank will say, yes, that's great. But if you can tell the person, listen, if you pay regularly and you do this and this, then we can offer the loan at 10%, maybe that's something that we as data practitioners should investigate and make that an option for the person. No, I disagree with that. So you can...
I think we can look at it more like it's a suggestion you make to the person. You're not forcing them to do anything with the information you give them, but I understand there's a fine line between...
This is exactly the same thing as Cambridge Analytica did. It's like, this is your profile, this is what we're giving to you, this is your expectation. So
yeah.
Yes.
Yes, in a different way. Yes. My argument about the capitalist answer is that I feel that if we encourage these options, the bank that offers the ability to give 10% loans will generate customer loyalty and customer respect and hopefully increase their total number of customers. So there is a way to also spin it as it's also incentivized for the bank. Of more people. Yes. Yes. But I feel these are the sort of questions that we should at least ask ourselves. Back there.
I think these discussions are really interesting to have amongst like AI practitioners and data scientists, and we think they're important to have. I think we're all starting to agree they're important discussions, but I think the discussion should also move to the companies that we are employed by who are leveraging these technologies. You know?
Yeah.
We can discuss the ethics of I can go do this and I can go do that. This is more ethical, but the decision about what to use often doesn't come down to you as the data scientist. It comes down to the person who's deciding what they want to actually aim their strategy at.
Yeah. Yeah. No, but in a way, then we become gatekeepers because we can tell people what are the options. Which makes it important that we do think about the implications of our recommendations. Alright, going on to the next one. So yes, it's weird like balancing the capitalist applications of these things with the ethical implications. So what we did over here is find individuals, so that's just an example of that, but individual people that you can identify, and then you can also, the tool that we built is that you can extract the information. So you can see who the individual people you are that you target. You can set your filters for should it be close to a post office or far away. Should it be high LSM, low LSM. And that way filter your customers so that you target your customers accordingly. Another application of this is, for example, how to open stores. So you can, based on your profile, you put a grid over the previous, say, here. You can put a grid over this and cluster the entire South Africa. Say, create 100 different clusters. And then if you have a certain type of store, say Woolworths, you can see what type of clusters you are profitable in, which type of clusters you're not profitable in. So if you need to decide where to open your next store, you simply look at, even though you don't have any store there, which clusters within the space is profitable, which clusters are not, and then you try and open the stores in the potentially profitable areas and those that are not. You can also do all sorts of fuzzy clustering to know which is the most likely place to put it, etc. And then also optimize so you don't have too many profitable places in one place, but spread it over the entire geographical area. Which brings me to another thing about the curse and blessing of high dimensionality, is that the great thing is now we've got a lot more data with which to work with. But in the traditional sense of sort of machine learning and predictions, is that you need then all that information to make the prediction. So if you included 10 factors in your GLM model or your neural network model, so income, age, gender, etc., education levels, then when you want to make the prediction for that person, you then need to go and gather all those 10 variables. And if you don't have that variable, how do you make the prediction? So in a normal sense, if you only gather 8 of the 9 variables, or 8 of the 10 variables, then you cannot make the prediction. So this is also, so that's a curse of high dimensionality. And that's then where it becomes important that you do things like data imputation, collaborative filtering, and also the Bayes approaches that we've had discussions about earlier, as trying to find ways to then fill the missing data in a smart way, take the marginal distribution to populate the missing data. So what you can do if you have the person's location and his, say, preference from one of these products, then that is a starting point. So then you can give one recommendation to a person. And then as you get more information about him, the type of recommendation to give them can change dynamically. So for example, if you want to give a person a loan, if he only has basic information to give you, you offer it at a certain rate. But if you can provide additional information, instead of just saying, no, you don't give us the information you want, we're not going to give you a loan, you can tell them, well, if you're going to give us this and this information, then we can update the terms and improve the terms of the loan as you go along. So make it a dynamic recommendation that you give the person. Instead of a fixed, this is the product we're offering you, you've got no choice, you can tell them, okay, we know these 3 factors about you, and that makes you qualify about this loan. If you can change or provide us information about these other 7 factors, then we can improve and give you a better loan or better terms for your product. Yes. Yes.
So there's only so many things that people have choice of. They're being discriminated against in different countries.
Yes.
And that's when it becomes
Yes, but I think it is important that my solution around it is that you should at least make the person aware of the factors that is driving the decision that we're making for him. So even though he cannot do anything about them, I think it's different from assuming the worst and then offering him the worst if that person doesn't give that information. Instead of saying, well, you haven't given us that information, so this is what we're assuming. And then have a two-way system in your recommendations instead of just a one-way. Yes. Yes. Yeah.
This incentivize some people to give information, for instance, health information. If they know it's negative, then they won't give you information. This is somebody who knows.
Yes, so that is selection. So somebody will anti-select against you. Somebody who knows they have cancer will try and avoid any questions around cancer. Somebody who has HIV will try and go to products where they don't test for HIV. But the thing is, if you have a dynamic system, you can make sort of assumptions around what's the likelihood. So you increase his loading for HIV, whatever the factor is, automatically. And then you have a system that can work dynamically. And as if the person does give the information, you incentivize him to tell him that you have HIV, or you don't have HIV, to go for the test and then reduce your premium. Or you give him systems with which you can control his HIV so that you can say, well, we'll keep the rates the same if you follow these things in order to manage your health appropriately. So that is my solution towards that, even though. Yeah.
About the ethics regarding providing those large-scale stores to
Yes, you could. You could argue that way.
Yeah, the fiduciary responsibility to shareholders to maximize. For day trading.
You could argue in a communist society you wouldn't have given any choice. So, like,
Getting very deep in this.
yes. So what I want to conclude with this is that the curse of high dimensionality is that we need to be able to work with dynamic systems, be able to work with information that's not complete and still give answers instead of expecting, as our old models, to have all the information before you make a recommendation.
Are you implying that if they say don't tell you that they have HIV, then they have a very high premium, and if they do tell you and it is positive, then it's lower, and if it's false, then it's even lower than that?
That's one possible solution.
Okay.
Yes. Those sort of things. So we've talked about places how we can get big data. There's lots of amazing things like weather information. So this is from Weather SA last year. And you can see it's raining everywhere except for the Cape. But yeah, you can pull in weather information. You can look at crime statistics and how crime varies. There's lots of amazing open source data out there that you don't have to like take from a person without them knowing. Yes.
You can set up a camera and collect it yourself. So
Yes.
I haven't seen anywhere you can get that. Might be able to jack it out of like a Waze or something, or at least get the wiki seasonality.
Yeah, that is so scraping data is an art form that Alex has almost perfected.
But I haven't seen that. Let me know.
But some of the things you can just buy, and they're probably worth buying. I think Cape Town is working, the city of Cape Town is trying to start recording that sort of information because it helps with their own road maintenance, if they know where the potholes is and where the traffic is. I'm running seriously out of time. The other thing that I wanted to say is you can, with OCR, we've had lots of discussions about OCR, get lots of structured data out of otherwise unstructured data. And the different blocks reflects different types of data, and that allows your predictive model that then builds on these sort of things to be much more accurate. And the point is there's lots of information that we don't gather but have on people and on our clients. So if you do underwriting, somebody would like write on a form that the person has a bad back, but he doesn't anywhere else capture it. And therefore you need to be able to extract written information from the underwriter into structured data in order to make proper decisions in life insurance, for example. I'm actually running out of time soon. Word2vec is another important thing, is in order to understand the context of data. So it is very similar to a convolutional neural network, because you need to look at what happens before it and what happens after it. What is amazing about it is that you can get a number, and if you plot it, things that are similar gets plotted close to each other. So the word in the middle, depending on the context, words before it and words after it, something like kitchen and table and bathroom is very close to each other. So even though the person may use a different word for, he uses LG instead of Samsung, you don't need the actual word. You just can get something that's very close to it in the semantic space, and that allows you to have a much better predictive model than just using a bag of words, by looking at words that are close to it if you don't have the exact word in your corpus of data. And then, of course, things like when you make a prediction, you should not just look at the price or the things that's easy to get. As data scientists, we should be pushing ourselves to also look at the hard information, not throw away the hard things, but try and use the hard things where possible to make our predictions.
Okay.
That's it.
10 minutes for questions.
Yes, there's two things I wanted to say to close off. One is, like I said, the blessing is that we can give much better recommendations and hopefully not just make more profitable recommendations, as we've discussed here, but useful recommendations. So telling the person the closest place to get help for some sort of form, instead of just telling him you should go and pay his bill, telling him, giving him useful information, so tailoring it based on his location, etc., is a useful application of analytics, but it's up to us to sort of understand where to apply it appropriately. When is it discrimination and when is it useful? Then the ability to explain, or the last thing I wanted to say, is that one thing that we do need to develop is ways to explain our results. Explain to a person why it was given a loan or not. Explain to a person why we're giving this recommendation or not. Because that improves both the trust that we have in the system and encourages a person to have positive feedback with us, having it a two-way discussion and interaction with us. So that we shouldn't just have black boxes. We should have the ability to explain our decisions and have a two-way conversation. We should be able to work with incomplete data, as I said. And then the last thing, we should learn to think outside of the box and not just be the persons providing the answers, but also be the people who are asking the right questions. Thank you very much. I think we've had lots of questions, but yes, we've got time.
I want to ask you, just in general, do you think like the curse of dimensionality is applicable only when you want to make inferences, not necessarily predictions? I think the curse of dimensionality isn't applicable when you try to make predictions, because if you're thinking right, it's right, so if you feel the black box models or what dimensionality it is, but when you make inferences, that becomes a problem, because correlation doesn't necessarily mean causation.
Yes. I think it's an important point is to understand the differences, and I think with these sort of black box models, we do implicitly make that assumption. So I think if you are able to explain how your model works, and you can see that the recommendations that you make is nonsensical, that it cannot be causation, it's just correlation, then I think that is why you need to be able to explain why your model is making decisions that you're doing, that you're not discriminating against somebody based on just a black box.
But neural networks are purely correlation, not causation.
Yes, not causation, yes.
So that's like most models, except like instrumental variables.
Yes, but, yeah.
Sorry, go ahead.
No, but what I was trying to say is that just the black box itself is just causation, or just correlation, not causation. But if you have the ability to work backwards and understand which factors, input factors, are driving the output of the neural network, and be able to identify this is the strongest input, then it comes back to causation. And then you can see, is this cause that we're assuming, is it ethical or not? Is it right to use that as an input to offer the person a loan or not? So we need to develop ways that can do that.
But it seemed like you were asking about more columns versus explainability. Like typically, yeah, more columns. You can't visualize 10,000 dimensional space easier than 3-dimensional space. So generally, more columns does mean you're going to get more accurate predictions, provided you have enough rows to support it. But you can take a lot of data, put a great model, and then put a simpler model and use that to try to understand, or use random, like something what Stuart was discussing around random forest. Or something like the PCA to try to visualize PCA over time, see how clusters move from default to non-default in PCA space.
So just to follow up as well, in terms of explaining the models, a lot of the techniques seem to be good approximations, not really full-out explanations. Do you have any kind of suggestions in terms of techniques that you choose to explain the model in a regulated environment?
I do have explanations as part of my master's thesis, and some of it my professor will be highlighting soon. So, yes, so there are ways. PCA is one way of doing it, to get a lower two-dimensional space, and then plot your decision model in that two-dimensional space and see in biplots which factors are driving the decision or not.
Come to Professor Number's lightning course.
Yes. I don't think the people in that. Yeah, I can bring my mic. Sorry, it's very hard here too. Okay.
Question and answer.
Yes.
Say what you're answering because we can't track it.
Yeah. So sorry about that. Is there? I just realized it.
If a client goes to a regulator and says, I believe I'm denied based on my skin color, there should then be some oversight on the provider. They can say, okay, here's access to our, not the nuts and bolts of it, but you give us some input. Here's my TC.
So just quickly on that, that is a requirement under Basel III for banks, is to be able to explain how the model works. And a client is able to go to a bank and say, why did you give me a loan or not, and what's the factors driving it? And
Be able to explain it, or do I just need to be able to demonstrate on input output to say, okay, here's the representative input, here's the representative output?
yes, but I feel that is, yes, but I think that is where us as data scientists need to push the theory out there, what can be done, so we can give exact answers for individual cases instead of just generalized answers. And that's up for us to develop that.
So, strictly speaking, like, if someone potentially dodgy is walking towards you and you make the decision to cross down the road, you can't really explain why you make that decision.
That's exactly it. I mean, you need to be able to...
Maybe you can try, but that's going to be a post-hoc rationalization of a core process that probably was beyond your grasp.
It sort of seems a bit unfair that we're expecting predictability from the results of these algorithms and we can expect
People are getting triggered.
Yes. Three more questions. Any more questions? Or do you want to just...
So how do you deal with the bias in data? So we have biases in our models because we're building them and we're humans. Now, the way we collect the data is biased. And we got this complexity, so they're hidden. Bias is hidden in the data. So how do we deal with that in this sense?
I don't have answers. I think that is where maybe you should think through your collection process beforehand, not just collect and then build the model afterwards. But
So I think the best you can do is state your assumptions. The same way that if you publish a peer-reviewed, the question was, how do you deal with the inherent bias in the data because you don't even know the bias because you made the model. The best you could do is state your assumptions, and other people peer-review it and go, you made an assumption here. And you go, let's test the assumption. And then if you do that enough, hopefully it passes peer review. But for that, you have to publish your assumptions and your model.
Maybe that is something that even internally when we build models is follow that sort of scientific approach, that you should state your assumptions and be open for peer review as data practitioners. I don't know.
One of the ways that this kind of thing can make the world a better place is it's not that that bias is being introduced artificially here. The world is biased, but maybe if there's a standard way of showing that bias, then that's the start of making things better.
Yes.
But there's a bias. If you're rich, you get a cheaper premium on your loan than if you're poor. There's a bias in the
yes.
That exists already. So
that exists whether it's algorithm or human making a decision. But maybe if there's a standard way of, here's how decisions are made. Here's a representative visualization of how these decisions are made. Actually, it's bias exists. It always has.
Yes.
Now we can see it.
At least acknowledge it.
Okay, thank you, Adriaan. That turned out to be a very controversial topic. But I mean, with any technology, it can be used for good or evil. So thank you, Adriaan.
Thank you very much for all the questions. I appreciate your open discussion.